What's poppin', dogs? Mr. Allen here with the Algebra 2 Honors Semester 2 Finals Review. We got Module 3, Topic 1, Radical Functions Review. All right, a little scene change here. Decided to change places, right? So let's get after it, dogs. Let's get going. What does it mean for a relation to be a function? All right, so I think really what would be the best thing to write down here would be, rather than what does it mean, but it needs to pass the vertical line test. So if we have this graph of this function here, right, and a vertical line only passes through it once at any given point, then it's a function, okay? Then what does it mean for a function to be invertible? That would mean that the inverse of said function is also a function and would pass that vertical line test itself. Alrighty, on to some transformations here. We got each of the functions below represent transformations of a function y equals the square root of x, right? Transformations from that function. Describe the transformations. So first one here, I'm going to switch to green here. We have ourselves a vertical reflection, which we could also write as a reflection over the x-axis. Next, okay, so we don't have anything on the inside there, so no horizontal stuff, but it does go up 2. Beautiful, wonderful, fantastic. Changing the marker. We're going light blue, man. Oh, man, I'm feeling crazy with the light blue. Hopefully it's not too light. Okay, so now let's see here. So the inside of this function, this is a little bit crazy here. We're going to have to rewrite this thing. So I've got f of, whoa, that is, hold on. There we go. That's a little bit better. So the inside here actually needs to be factored before we can analyze it. We haven't done too many of these this year, so we probably wouldn't throw in like this, quite like this on the test, but I'll go ahead and show you anyways, and then we can analyze from here. So I'd have to take out that 2 there, and then I'm going to have minus 3 over 2, because if I multiply that 2 back in, I'd get back to 2x minus 3. And then we have minus 7 on the outside. So now that we have it in this factored form, we'd probably give it to you in this factored form, since we didn't really cover that too much. I'm going to have a horizontal not stretch, compression by 1/2, so that 2 there, reciprocal because it's on the inside. So it's a horizontal compression by 1/2. Then I have to go right by 3 over 2, and then we're going to go down 7. Okay, so factoring out of that 2 is key because it doesn't go to the right 3. It goes to the right 3 over 2. All right, again, we didn't do tons of those with the factoring out. So if you're like, I don't know about that, bro, don't worry too much about that one. You should be all right. All righty. Well, this next one here, this one we would also have to factor out that negative there. That's not too crazy. I think it's really when we start dealing with the fractions and things, it gets a little bit nuts. But we're going to have x minus 7 then on the inside of that radical. Okay, so now I have a vertical stretch by 3. That negative on the inside is going to be a horizontal reflection, which we can also say is a reflection over our y-axis. And then lastly, we're going to go to the right 7. All right, opposite sign there, so right 7. Moving on to 4. Whoa, went a little bit over. There we go. Okay, 4a. So this one here, into our some inverses and things like that here momentarily. So we have graph f of x equals x plus 5 quantity squared minus 3 when x is greater than or equal to negative 5. Okay, so we're just dealing with half this quadratic here essentially, right? So if we're going to graph that, my vertex is negative 5 comma negative 3. So negative 5, negative 5, negative 1, 2, 3. And then if you remember your patterns from quadratics, you could just go up 1 over 1 and then up 3 over 1. Or you can go ahead and plug in negative 4, evaluate. We get 1 squared is 1, minus 3 is negative 2. And then I can plug in negative 3, excuse me. I'd get 2 squared is 4, minus 3 is 1. So either way, I'd get those ordered pairs. You could do a little T-chart action. I don't really care for that quadratic. Let me try that again. That's a little better. That's a little nicer. And I'm going to emphasize these points here a little more just so we, because we're going to be using them here momentarily. All right. So what's our domain? Well, it actually gives it to us. X is greater than or equal to negative 5. My range, what is it always larger than? Y is always larger than negative 3. Cool. Beautiful. Next up, it wants us to find the inverse of the given, find the equation for the inverse given the restricted domain and graph the inverse on the axis provided. I'll switch to red for this one here. And let's see here. First thing we got to do is I like to write it with y equals first, right? Because then my next step is switching my x and y's. Why did I write to the 5th power? There we go. And then minus, that's a very low minus there, minus 3. It's a little hard sometimes writing on this thing because it's like vertical. All right, so then I'm going to have x equals, and we have y plus 5 squared minus 3. And then I'm going to resolve for y. So I add 3, I get x plus 3 equals y plus 5 quantity squared. And now I got a square root on both sides to undo that squared, okay? So red, there we go. So now what I'm going to have is y plus 5 equals, and it's plus or minus the square root of x plus 3. But because we're dealing with the right side of our quadratic, the positive side of our quadratic, we don't need that negative. So we have y plus 5 equals the square root of x plus 3. And then I'm going to subtract that 5. So y equals the square root of x plus 3 minus 5. So proper notation here to be f inverse of x equals the square root of x plus 3 minus 5. Now we could graph this using what we know about radicals, or I can just switch my x and y's. So I had the first point was negative 5, negative 3. So now I'm going to have negative 3, negative 5. Whoop. And then the next one was negative 4, negative 2. So I'm going to have negative 2, negative 4. And then the next one was negative 3, positive 1. So I'm going to have 1, negative 3. And I'm going to have this beautiful looking radical function. Radical. All right, and you may may want to note or remember or recall, right? Don't you love when books say that? They're like, please recall from this day 18 years ago. No, bro, I'm not going to remember. It does reflect over this y equals x line, right? So if I see that, boom, okay, look at those two. It does look like they kind of flip over there. When it doesn't work, you kind of know, you're like, that don't look right, bro. But this one, it do look right, bro. Okay, beautiful. Next one, we have find each domain and range of the functions. All right, so we have h of x is x plus 1 quantity squared plus 1 when x is greater than negative 1. So there's my domain. It gives me my domain restriction. Isn't that beautiful? And then I got to find my range. Well, let's think about this quadratic. It's going to have a vertex of, so vertex is going to be negative 1, comma 1, right? And it's always going to be up. So my y has to be greater than or equal to positive 1. That's going to be my range restriction on that one. Because I'm going to have this point here. It's going to be it's just going to be like that guy right there, okay? And that's that point. So it's always going to be above positive 1 if we think about it like on the graph in that last problem. So now it does ask, it looks like, for the equation here. So we are going to find that equation, but I can easily pop in my domain and range right now. This is going to be x is greater than or equal to 1. This is going to be y is greater than or equal to negative 1. The values of that are associated with domain and range just flip-flop just like our ordered pairs, right? So to save a little space here, we're going to have x equals, and then I got y plus 1 quantity squared plus 1. And then I got to resolve. So I'm going to subtract 1. I get x minus 1 equals y plus 1 quantity squared. And now we know that we can actually get rid of the negative there, right? Because it says x is greater than or equal to negative 1. If we said x was less than or equal to negative 1, it would be the negative square root here. So my final, we'll just go ahead and, well, I guess I can write y equals square root of x minus 1 minus 1. And that would be my inverse there. All right, so I'm going to have square root of x minus 1 and then minus 1 on the outside. Boom. There we go. Beautiful. Fantastic. Wonderful. Now we're going to rewrite the radical in exponential form here, number 5, which is one of my favorite things to do. Not really. Okay. So the root is my denominator of the rational exponent. Right? It's a rational exponent, which is a fraction for an exponent. So we're rewriting the radical with rational exponents. Okay. So we have x, and then it's going to be 2 over 7. So my exponent is in the numerator. My radical, right, my 7th root, that goes to the denominator, okay? So the same thing will apply here on this next one. I'm going to have x, and it's going to be 5 over 15, which simplifies down to x to the 1/3. third. There's my answer there and there. All right, next one. So if there's no number written there, remember it is a square root, right? OG root, you know what I'm saying? So we got y equals, and then it's gonna be, not y equals, what am I doing? Y to the, and it'll be 9 halves. All right, next one here, square root, x to the 1 half. Done. Beautiful, fantastic. Now we finna go the other way, right? So again, the denominator is my root. So I'm gonna have the 9th root of x to the 4th. And then here I'm gonna have the 5th root of y squared. And here I'm just gonna have the square root of z, yay. And here I'm gonna have the cube root of b. Isn't that dope and fun? Okay. Now we wanna rewrite each radical. We want to rewrite each radical by extracting all possible roots, and then write the final answer in radical form for x is greater than or equal to 0 and y is greater than or equal to 0. So that x and y being greater than or equal to 0 really just tells us we don't need to worry about any absolute values, because any numbers that were plugged in there are guaranteed to be positive regardless. So no need to worry about absolute values in this one, which is absolutely fantastic. Get it? All right. So 36, is that a perfect square? It is. So it's just going to be 6. And how many pairs of x's can come out? There are 5 pairs of x's. That one's done. All right. Is 32 a perfect square? No, it's not. But I can break it down to 2 and 16. 16 is a perfect square, and I'm going to get 4. And then how many pairs of x's can come out? 1. How many pairs of y's can come out? Well, I get it 2, 4, 6, 8. So 4 pairs. Right? And I'm going to have 1 left over, along with that 2, and then we'll have the y. Beautiful. Some people would like to continue on with the factor tree and circle pairs. I like to, do some cool things like that, like, oh, I see a perfect square. Just square root it and bring it out. That's kind of dope. All right. Next one here. We've got the cube root, so we're looking for groups of 3 now, right? Now, if I break this down into 2 and 125, you may recall, because logs are fresh in your head, 5 to the 3rd power is 125. So that means that a 5 can come out, right? And then the 2 will be left in the radical later on. How many groups of 3x's can come out? 3, 6, 2 of them, right? So x to the 2nd. How many groups of 3y's? 5 of them. So we get y to the 5th. Nothing left over for the y's. But now I got my cube root. Make sure you pop that 3 back in there. The 2 was there and an x. There's my final answer. All right, and lastly here, 4th root. My goodness, we're pulling out all the stops. Again, since logs are fresh in your head, you might remember that the 4th root of 81 is 3, because 3 to the 4th power is 81. So 4 is going to come out. So I'm going to have 2 times that 3, which will give me 6. That's going to come out here. And then how many groups of 4 x's can come out? We got 4, 8, 12. So that's 3. So x to the 3rd. And then I've got how many groups of 4 y's? Only the 1y there is going to come out with 2 left over. And that x, I had 1 left over, right? So I'm going to have the 4th root now, 4th root of x, and then we got y squared. That'll be my final answer for that one. And again, if you're wondering, like, wait, how did we get that 6? It was that 2 times 3, the 4th root of 81 is 3. So that's how we got that 6 right there. All right. Now we've got ourselves some solving of radical equations here, right? I'm not going to stop with the radical anytime I say it. So what's our process for solving radical equations? If we get the square root on its own side, then we can square both sides to undo that square root. So I'm going to square both sides since it's already set up for that. And I'm going to get 3x minus 5 equals 25. Cool. All right, and then I got to add 5, so I'm going to get 3x equals 30, and now x equals 10 when I divide by 10, right? And I do need to check for extraneous solutions. Since there's domain restrictions associated with radical functions, I can't have negatives in there, and they're not going to produce a negative answer, right? I got to check for those things. When I plug 10 in, we are all good there. It's positive on the inside. All right, next one here. I have the square root on its own. I got to square both sides. And you got to be careful with this one because it's a binomial on the left. So we are going to have to FOIL this, right? It's going to be x minus 5 times x minus 5 equals x plus 1. So I'm going to have x squared minus 5x plus 25 equals x plus 1. And I'm going to have x squared minus 10x plus 25 equals x plus 1. And oh my goodness, we have a quadratic, right? We probably noticed that a little bit earlier, but saving the suspense, right? So we're going to subtract x and subtract 1. I'm going to get x squared minus 11x, and then we have plus 24 equals 0. So what multiplies to 24 and adds to what? Negative 11? How do you ever, oh yeah, 8 and 3. Okay, so x minus 8 and x minus 3. That's going to do the trick, right? 8. All right, equals 0. So I'm going to get x equals 8 and x equals positive 3. Now, if I plug in 8 to my original, right? If I plug in 8 to the original, I get 3 on the left, I get square root of 9 on the right. That's good. If I plug in x equals 3, I'm going to get 3 minus 5 equals 3, the square root of 3 plus 1. So I'm going to get negative 2 equals 4. Square root of 4, excuse me, which is 2. I'm just going to do that right there. Whoop, boom, 2. That's not true. Extraneous solution. Yes, we got one. We didn't have an extraneous solution from the entire rational solving, but now we got one, right? So an extraneous solution, all right, this is a great multiple choice question. You ready? I'm going to set this up. I'm going to put this on a silver platter for you. All right, an extraneous solution comes from proper algebraic steps, right? Working through the whole thing, solving it properly, but it does not work in the original problem, okay? So you go through all the proper algebraic steps, but it does not work in the original. I'd write that down. I'd jot that down right now and be like, I'm gonna get that question right on the test. I don't know if it's on the test. Oh, wait, I wrote it. Hope I don't get in trouble for, spoiling the big news there. Oh, boy. Alrighty. So now, this next one. Oh, boy. Oh, boy. I can't isolate the radical. So we are going to just have to square both sides. Just kind of muscle through this one, all right? So boom, boom. Oh, my goodness. We can see the finish line. Look, module 3. Next one. Yay, we're almost done with this video. All right. So let's see here. We've got ourselves, we're going to square both sides. We got 9 now because 3 squared is 9. And then we have x plus 3. The radical cancels, but that squared part has to distribute to that, right? Okay. Equals, and then I'm going to do the same thing here. 4 squared is 16, and then that's going to cancel my radical, so I'm just left with x minus 4. And now I can distribute. So distribute here, distribute there. All right, so we got 9x plus 27 equals 16x, and we got minus 64. And let's see here. I'll bring my 9x over, so I'm going to get 7x. Add my 64, that's going to be what, 91? I checked it in the TI. I was not confident. All right. So, yeah, so we get 91, and then we're going to divide by 7. And although we think probably nothing can be divided by 7, like when they get big numbers, but it is actually 13 here, contrary to popular belief, kids. All right, and if I were to plug that back in, I'm going to have positives inside my radicals. We're all good on that one right there. All right, next one here. This one's going to be a quick one. Do you know why? Oh, okay, so if I subtract 12 on both sides, I'm going to get the square root of 2x plus 7 equals a negative 3. Boom. Now, can a square root ever equal a negative? No, it doesn't matter what I square root. It's never going to equal a negative. If I square root a negative, I get an imaginary number, and we're not dealing with that right now. So this one here, no solution. So, if I were writing a test, right? If I were to write a test and I want to, be a little spicy with a problem here, perhaps I could say which of the following has no solution, Which of the following has no solution? And people might go through and solve every single one of them. But if you know what to look for, that's a quick problem right there, right? If a square root's going to equal a negative, no solution, right? So there you go. Another pro tip right there. All right, last one here. We are going to bust out the TI for this one, I'm thinking. So Mary deposited $1,730 in an account 4 years ago. Now, the interest is compounded once a year, and you can use the equation r equals the cube root of a over 1,520 minus 1 on the outside to relate the current balance a and the interest rate r as a decimal. If the interest rate is 6.5%, how much does Mary currently have in her account? Round answers to the nearest cent. Hint, write the interest rate as its decimal equivalent before substituting it into the equation. Okay, yes, we should definitely do that. I'll read the hint, but I think a lot of us knew that, but just a friendly little reminder, right? So R is our rate, right? A is the current balance, and we're trying to find, right, that balance, right? So let's go ahead and solve this thing for A. So my rate is 0.065 equals the cube root of A, which we're trying to solve for, over 1520 minus 1. So what's the first thing we need to do here? I'm going to add 1 to both sides. So add 1, and I get 1.065 equals the cube root of A over 1520, right? That's a kind of a terrible A. That's a little better. All right. Now, what do I do to get rid of this cube root. I'm going to cube both sides here. All right, now we're going to have to bust out that TI. So I have 1.065, so 1.065 raised to the third. So I'm going to hit that little caret right there and type a 3, hit enter. All right, and I get that 1.207, and I'm just going to jot that down right now. 1.207 and change equals A over 1520. Now, what am I going to do to solve for A? One last step here. I'm going to multiply by 1,520. So 1,520 on both sides. So in my calculator, because that's gone now, in my calculator, I'm just going to hit multiply by 1,520. Okay? Hit enter, and I get $1,836.08 because it says nearest cent. So 1836.08. I think it was 0.08. The calculator went away from me. I know you can see it, but I can't. There we go. That's perfect. Beautiful, wonderful, fantastic. All right. Now, one thing I want to point out with this thing here and why it's so dangerous to not YOLO. You only round once, kids. All right, so check this out. If I were to have rounded that 1.207 to say 1.21, and I multiplied that by the 1,520, right? And I hit enter, we get $3 off, more than $3, right? That's a totally different answer, you know? So that rounding error has now been multiplied 1,520 times over and continually gotten further and further off. Now, that might not seem like a big deal to you, but it's a big deal to me, right? Okay, it's a very big deal. And it would be the wrong answer on your test. It'd be like, why isn't the answer here? It's because you rounded and then rounded again at the end. So only round once, right? That is a key, piece there of like when it actually applies, okay? That's it for this one, guys. So thank you for sticking around for this wonderful video here. I know they get a little bit lengthy, but the grind is real for finals, right? The grind is real. So there we go. Module 3, topic 2 and 3. We're going to combine that one into one. That's the final video that we'll have here. And then that's it, bro. That's it. You guys have a wonderful day.